Hello, welcome to 3.8. It's the last section. You're almost there. Here we go. All right, we are going to be talking about 4 different characteristics of graphs. We're going to start with increasing and decreasing, and then later on we're going to talk about end behavior. So increasing and decreasing is kind of exactly how it sounds. Is the graph increasing or is it decreasing? Now, what we mean by that is as you move left to right, are the y values getting bigger, staying the same, or getting smaller? That's what we mean by increasing. So I'll give you the math definition, and I'm going to give you the roller coaster analogy here in a minute. So if we look at our increasing values, so this is an example of an increasing part of the graph. So again, as you move left to right, so notice how the graph is going down towards the left. I get that, but remember, increasing and decreasing is always as you move left to right. It's as you read, otherwise known as. So here, as you move left to right, it is going up, so therefore it is increasing. So then we have this idea of constant. So constant, I think, is pretty obvious. It's when the y values are staying the same. Again, as you move left to right. And then last but not least, you have decreasing. So again, as you move left to right, are the y values going up or going down? And for decreasing, they are going down. So the roller coaster method. So if you are on a little roller coaster here, are you going up and down? So the roller coaster goes up, it's increasing, roller coaster stays the same, it's decreasing, roller coaster goes down, it's decreasing. So again, as you move left to right, or as you like to say, like if you were on the Batman or the Boss or whatever at Six Flags, as you go up the roller coaster, if you're going up the hill, it's increasing. If you're staying the same, it's constant. And then as you go whee down the hill, it is decreasing. So that's the first concept. Let's do some examples. All right, so we're just identifying where it's increasing, where it's increasing, where it's decreasing. So we look at this graph. As we move left to right, it is going up. It is always going up. So it is increasing along all real numbers. And it is decreasing none of the time. So I'm just going to write all real numbers and none. So again, as we move left to right, it is only going up. So that's where that comes from. We look at number 2. It's the exact opposite. It is always going down. So lines are only going to be either increasing or decreasing if it's a solid line. So none, it's never increasing, and it is always decreasing. Another way to write that is going to be negative infinity to infinity. Love my infinity sign. Okay, these are a little bit more interesting. So we have a turning point here. So it's going to be increasing. So as we move left to right, it is increasing up to that turning point. So we're going to write from negative infinity to whatever point that is. X is 1, 2, 3. So we'll do from negative infinity to 3. So our intervals traditionally always are referring to the x coordinates. The only time we use y coordinates is when we're talking about specifically the range. Everything else is just based on x coordinates, just so you know. Okay, so then our decreasing interval starts at 3 and goes on forever. Same thing for number 4, just kind of the opposite. So it starts off as decreasing. So I'm going to write that on my decreasing. That's going to be negative infinity. Oh my gosh, my infinity signs are terrible. Negative infinity to whatever point this is. That's at negative 1. X equals negative 1. And then it's increasing left to right, going up from negative 1 to positive infinity. So increasing and decreasing. Okay, so we've got some parabolas. That should be fine. It's the same concept. It's convenient to know our vertex, but as we move left to right, we're going down the roller coaster, so that means we're decreasing. So I'm going to put negative infinity to 1, 2. And then from there going up, we're increasing. So it's going to be 2 to positive infinity. And same thing over here. We're going to put our vertex right there. And it's increasing from negative infinity to, what number is that? 1, 2, 3, 4, 5. And decreasing from 5 to infinity. Okay, so the next characteristic is called end behavior. So this idea of end behavior is as we go off into infinity along the x-axis, what does the graph do? Does it go up forever? Does it go down forever? Or does it stop at a certain line or something like that? So the way we say that, or the way we write it, looks like this. So you have to pay really close attention. So so the way this reads is, as x approaches infinity, f of x, or y, approaches what? So if we were to look at the graph over here, as x approaches positive infinity, that's going to be going this way to the right. So as we do that, our graph is going down forever and ever and ever and ever and ever. So again, this reads, as x approaches positive infinity, f of x approaches negative infinity. So there's a bunch of infinities here, so it's easy to get confused. So that's why here you might want to just slow down a little bit and make sure you're reading carefully. So the other side of the equation, as x approaches negative infinity, f of x approaches positive infinity. So a couple of things to note. This part right here is basically another version of y. And then this part right here is referring to the x. So that's kind of a little bit of review, but it's good to know that, or good to remember that as you read these things. So we're doing end behavior, so let's do some examples. All right, let's look at some of these examples. So I'm looking over here at number 7, and we've got a straight line, and again, we are looking for as x approaches infinity. So what that means is that as we go further along this x-axis, what happens to our function? What happens to our line? How do we describe that end behavior? So as we go on to infinity, this thing goes down forever. It's going to keep going down that direction. So what we would say is that as x approaches infinity, f of x, or y, approaches negative infinity. So then right here, as x approaches negative infinity, so that means as we go this way, what happens to our graph? So as we do that, our graph goes up and up and up and up. So we're going to say that as x approaches negative infinity, f of x, or y, approaches positive infinity. Remember, f of x is just a fancy way of saying y. Same thing down here. So this section is kind of all about reading and attention to detail and just kind of describing what's happening. So we can do the same thing over on number 8. Again, it's another line. So as x approaches positive infinity, so as we go to the right, f of x looks like it's going up, so it's going to approach infinity. And then as x approaches negative infinity, or whatever, as it goes that way, f of x is going down, so we're going to have negative infinity. Number 9, we got something a little bit more interesting. We have an absolute value. So, and again, read carefully. As x approaches positive infinity, so again, we're going this way, f of x approaches what? So as we look through here, as we go further and further to the right, what happens to our graph? And in this case, what happens to our graph is it goes up and up and up, so it approaches positive infinity. So then if we go the other direction, if we go this way, as x approaches negative infinity, we're going to be going up the other direction, and that's also going to be positive infinity. So this is where it gets a little confusing of increasing and decreasing versus end behavior. So here we've got an end behavior that is both positive, but again, if we were to talk, the problem doesn't ask this, but if we were to talk about increasing versus decreasing, it is decreasing as we go down, and then it's increasing as we go up. So it's just two different things and two different ways to think about it. Or it describes two different parts of the graph. So if we look over here at number 10, same thing. So as x approaches positive infinity, our graph goes down and down and down. So we're going to say negative infinity. And we're going to do the same thing on the other side, because as x approaches negative infinity, it's still going down. Okay, let's try a parabola. So we're looking at this graph. As x approaches positive infinity, so we are going to the right, what does our function do? What does our y values do? And it goes down and down and down and down and down, and it's going to go down forever. So we're going to say as x approaches positive infinity, f of x approaches negative infinity. So then if we go the other direction, if we go all the way to the left, as x approaches negative infinity, f of x, or y, is going to go to, again, negative infinity. And hopefully by now, once you kind of get practice at this, you can look at this graph and go, hey, both end behaviors are going to be positive infinity, so I don't even need to read. You should still read. But I already know that the end behaviors of both sides of these are going to be the same. So there's a pattern here. If you recognize the pattern, great. If you don't, you still need to look at the graph no matter what. But our parabolas, our end behaviors are going to be the same. Our absolute values, our end behaviors are going to be the same. And they're also going to be the same as like that a value out front. So if you see a negative sign, end behavior is negative. If you don't, then the end behavior is going to be positive. And then our lines, they're just going to be different. So if you have positive infinity on one side, it's going to be negative infinity on the other side. So these are just general patterns. You don't have to memorize them. More specifically, you need to be able to look at the graph and tell me about what the end behaviors are doing. So that's increasing and decreasing, aka the roller coaster, and end behavior. What does y do as x approaches infinity? There you go. That is our section. That's 3.8. And a huge shout out to Mr. Scheller for letting me use this wonderful recording studio.